Hi and welcome to Pre-Calc 20 with Miss Verity. Today we're going to be looking at 9.1, linear inequalities. This was something that we did in Foundations 20, and we're going to do it again, but with a little bit of zest in coming sections. So linear inequalities, basically you're going to graph the line. You're going to decide if the line is solid or dotted. And that comes from if you have solid is a less than or equal to, a greater than or equal to, a dotted is just a less than or greater than. And then you're going to pick a test point to see which side of your line is included in your solution. And that's where we would shade. So it would end up looking something like that graph on the side. So our first example, we want to think, what's your favorite way to graph a line? Personally, mine is y equals mx plus b. That is our slope-intercept form. So I would rearrange that equation to get the look that I want. Remember, if you are ever multiplying or dividing by a negative, your inequality symbol needs to switch. So we're going to subtract x to both sides, and we're going to add 6 to both sides. So we get 3y is greater than negative x plus 6. Divide every term by 3. If I want to change my divide there. We get y is greater than negative 1/3 x plus 2. So on my graph, I'm going to take my y-intercept of positive 2. That comes from our b. And we have a slope of negative 1/3. So I'm going to go 1 up, 1, 2, 3 over. And I'm going to keep continuing that pattern. 1 up, 3 over, 1 down, 3 over. Using a ruler, we would add a line, which I would hopefully extend. Ooh, actually, hold that thought. In our case, we have a greater than. That means, oh, I'm still on the circle mode, fun. That means we're going to have a dashed line. And we'll add arrows onto the end of that. So now we're going to do our third step, which is pick a test point. It can be any point on this graph. So I'm going to pick a point to me that just screams easy, and that is 0, 0. So picking the point 0, 0, we've got an x coordinate and a y coordinate. So we're going to insert those into our equation. The point you pick just can't be on the line you've drawn. So 0 is greater than negative 1/3 times 0 plus 2. So 0 is greater than 2. Well, that statement is false, which means this circle we drew, that point at 0, 0, makes the statement false. We always shade the side of the equation that is true. So the bottom half of our graph was false. We're going to shade the top half. And in an inequality, when we say like sketch the final solution or shade the final solution, the shading is the solution because any of those points in that shaded area would make the equation true. So again, when it says determine all of the points that make the following true, all of the points just means we are shading. So rearranging our equation, we're going to graph it. So I'm going to subtract x and add 4. Negative 2y is greater than or equal to negative x plus 4. We're going to divide every term by negative 2. That reduces to be 1. And because we're dividing by a negative, our inequality symbol is going to switch directions. We get positive 1/2 x minus 2. So that means a y-intercept of negative 2, a slope of 1/2. So 1 up, 2 over, 1 up, 2 over, 1 up, 2 over, 1 down, 2 over, 2 down, 4 over. Hold on, 1, 2, 3, 4. Beautiful. So we've graphed our line. We're going to think solid or dotted. We have a equal to, so we're going to have a solid line through those points. You're going to actually draw yours through those. Add arrows, and then we're going to pick a test point. So again, you could pick this point here and plug those coordinates in. You could pick this point here and plug those coordinates in. you could pick that point there and plug those coordinates in. But the easiest point, in my opinion, is 0, 0. So plugging in a 0 for our y and a 0 for our x, 0 is less than or equal to 1/2 times 0, subtract 2. 0 is less than or equal to -2. Well, again, that is false. And so we want to shade, so the top half of our line is false. We want to shade the side that's true. So that is our bottom half. If I had picked a different point, so say maybe this point had been my favorite. So that point is 1, 2, 3, 4, 5, -3. We would plug that into our graph. So -3 is less than or equal to 1/2 times 5 minus, I'm going to change this to be 4 over 2. -3 is less than or equal to 5 over 2 minus 4 over 2. -3 is less than or equal to 1/2. And that is true. And so if this statement is a true statement, -3 is less than 1/2. So we would shade the side that's true, and that's where our point is. So we're going to then find the solution for the following. We're going to do it graphically. So any numbers where x is bigger than 3. So with this, if you don't have an equal to, that is a open circle. So we would open circle at +3, and we want all the numbers that are bigger than that. Well, that is all the numbers that way. There we go. That's our solution for that one. We've got x is less than or equal to 6. A equal to is a solid dot. So at 6, there's our solid dot, and we want all the ones that are less than that. There's our solution. So next up, we are going to write equations for inequalities. So our first step is we're going to figure out what's the equation of the line. Some forms we know that are useful: y equals mx plus b. This one is great if you've got your y-intercept, which we do. So if we take y equals, if we count our slope, our scale is 1. So if we go 1 up, and a full over would be, or let's find our next point. Our next good point is right here. And that is 2 up, 1 over. So a slope of 2, x minus our y-intercept of 4. That was -4. So the only difference, we want to think solid or dotted. This was dotted, so that we're just going to have a less than or greater than, not an equal to. And basically, once to figure out what we want or which way we want our symbol to go, we're going to pick a point and on the side that makes it true or the side that makes it false. And based off of that, we know which direction we want to shade. So I'm going to pick my favorite point of 0, 0. So if we put 0, we need a symbol, 2 times 0 minus 4. So this was on our true side, on our shaded side. So we need an arrow that makes this true. So 0 is what then? -4. Well, 0 is bigger than -4. So our final equation would be y is greater than or equal to 2x minus 4. Writing the equation of this one, we've got a y-intercept of -3. If we're looking at our slope, we're going 1 up, 2 over. So our slope is -1/2. We've got a y-intercept of -3, so we can put that into y equals -1/2 x minus 3. If we pick a point on our graph, so again, I'm going to pick 0, 0. 0, 0 in this case is on the true side, so we need arrows to make it true. It's a solid line, so we need a greater than or equal to or a less than or equal to. So if I put 0 something is -1/2 times 0 subtract 3. 0 is what the -3? We want it to be true. So 0 is greater than or equal to -3. So our equation would be y is greater than or equal to -1/2 x minus 3. Last but not least, what's our plan for when we don't have an exact y-intercept? So that y-intercept is not on a nice, beautiful point. So we're going to remember what are other forms of equations we could write. We've got standard form, general form. We also have slope point form, where all you need is your slope and you need a point. So if we take this graph, we can count our slope. So let's find two nice points. Here's one and here's one. So we're just using that to count our slope. So we have a rise of 1 and a run of 1, 2, 3. So our slope is -1/3. And our point, you can pick any point on this graph. Doesn't matter which. Let's pick, 2, 0 makes, or -2, 0 makes a nice point. Again, you could pick -5, 1. Let's do that one just for fun. So y minus 1 equals -1/3. X, we would do subtract -5, but that is the same as add 5. So now that we've got our equation of our line, we know it is a dotted line, so it's going to be a greater than or less than, not an equal to. And we're going to pick a test point. Just to change it up, I'm going to pick -1, -1. And this one should be false because it is not on the shaded side. So if I plug those in, -1 minus 1 equals -1/3. I guess not equals, we're going to decide. -1 plus 5. So -2, we've kind of got our blank something. -1/3 times 4. -2 is something compared to -4/3. Remember, -4/3 is -1 and a third. So we want it to be false. Well, -2 we know is less than -1/3. -1/3 is bigger. So we want it to be a false statement. So if we said -2 is bigger than -1/3, that is false, and that's based off of because we picked this point, and we want that point, which we put into our equation, to be false. So our final version would be y minus 1 is bigger than -1/3 x plus 5.